So in this video, we're going to talk about negative exponents and how we deal with them when we see them in a problem. So let's just go ahead and do a little bit of backwards work. So we know that 2 to the third is 2 times 2 times 2, which is 8. And if I expand the rest of these, I get this. And we know that 2 to the 0 power is just equal to 1. So if I go ahead and I look at these in a vertical direction going down, I see that as I go from decrease the exponent by 1, so I went from 3 to 2, I actually divided the product by 2. And as I went from 2 to 1 in the exponent, so again, decreasing by 1, again, divided by 2. So every time I am decreasing the exponent by 1, I am dividing by 2. So when I go ahead and I take 0 and I decrease it by 1, I should take 1 and I would divide it by 2. And what do you get when you take 1 and divide it by 2? You get a half. And so then I would go ahead and do the same thing. If I go ahead and repeat that, I would go ahead and again take the previous product, divide it by 2 to get the next product. And I'm going to do that off to the side in case you've forgotten your fraction operations. So 1/2 divided by 2 is the same as 1/2 times the reciprocal of 2. And 1 times 1 is 1, and 2 times 2 is 4, so my product now is 1/4. And if I go ahead and I do that with the next one, decreasing it by 1 again, which means I'm going to divide by 2 again. So now I have 1/4 divided by 2, which is 1/4 times 1/2, which is 1/8. Okay, now let's do a little matching. So I'm going to look at the denominators compared in exponents a little bit. So here I have an exponent of positive 3 and an exponent of negative 3. And when I go ahead and I look at their products, I see an 8 in both of them. Okay, and now let's look at the 2 and the negative 2 exponents and their products, and positive 1 and negative 1 for exponents and its products. So what I notice is that when I had opposite exponents, 3 and negative 3, 8 and 1/8 are reciprocals. When I had opposite exponents, 2 and negative 2, 4 and 1/4 are reciprocals. Remember, a reciprocal is taking a number and writing it so its numerator and denominator are inverted. Okay, and when the exponents were 1 and negative 1, I got reciprocals again, 2 and 1/2. So the way that we go ahead and think about exponents when they're negative has to shift just a teeny bit. So a negative exponent, basically, one of the things we have to make sure is the base can't be 0, because remember, you cannot divide by 0, says that when you have a base raised to an exponent that is negative, you reciprocate it. And that exponent goes to its opposite sign. Not that it always becomes negative, because I'm going to show you just in a second, but that it just becomes its opposite sign. So another way of looking at it would be that if you had a negative exponent and it was in the denominator of a fraction, we could make it positive by moving it to the numerator. So a negative exponent becomes positive by going to the denominator, or if it's in the denominator, it becomes positive by going to the numerator. And you actually can do the same thing. You can make exponents negative by shifting into the opposite side of the, let's call it a fraction. So this is how I go ahead and I summarize it, negative exponents. And it just kind of, to me, just says, hey, I'm in the wrong part of the quotient. So let's go ahead and do a couple of practice problems. So let's say I wanted to go ahead and simplify 5 to the negative 2. So remember, We have our hidden denominator, just in case you're wondering about that fraction thing. Okay, hidden denominator is always 1 if we don't see it. And so if my exponent is negative, I'm going to go ahead and like using it like this. So to make it positive, I'm going to shift it from what's presently the numerator into the denominator. And because it's negative right now, it becomes positive. But remember, you can't leave the numerator empty, so it becomes a 1. But I can do 5 squared, so I get 1 over 25. So in this next one, I see a negative exponent, but you got to be careful about something. Remember that in the absence of parentheses, the negative 4 is only attached to the m. It's not attached to the 3. So the only thing that is being exponentiated, fancy word, by the negative 4 is the m. The 3 has a hidden exponent of positive 1. So the 3 is fine exactly where it's at. So the only thing I want to do is, when I'm simplifying this, is make sure I don't have a negative exponent. And so when I'm simplifying expressions, I usually want to end up with no like factors, and no like bases, and no negative exponents. So I have 3 is going to stay in the numerator. M to the negative 4 is currently in the numerator, but because the exponent is negative, I want it to now shift to the denominator. So it would be m to the 4th. Okay, and again, here's the way that we can use that property the other way. So currently, I have a negative exponent here. And we don't want to have this left with negative exponents. So it's currently in the denominator. So if it's in the denominator, to simplify it, I want to bring it up to the numerator. So 5 is fine the way it is because it has a positive 1 for an exponent. So it stays in the numerator. K comes up. Exponent becomes positive when we move it to the opposite part of the quotient. The denominator now has nothing left there, so it really is 1. But I don't need to write the hidden 1 in the denominator, so I would write it simplified form, 5 times k to the 3rd. Okay, now, this is a more advanced level for properties of exponents and with negative numbers, or with negative exponents, I should say. And you will be having to do this in Algebra 1. And I'm going to go ahead and give you a little taste for it, but you will have this as a bonus problem on assessments, but you will not have it on an actual assessment item. Okay, so first, what property would we use here? When we are simplifying, we want to follow order of operation. So order of operation says first we do any multiplication if there's no grouping symbols. And that's the case here. So I'm going to multiply my coefficients. I'm going to multiply my like bases. And my like bases are the x's. And they can get combined and the y's can get combined. So now I'm ready to go. So 15 times 3 makes 45. X to the negative 3 times x squared. Remember, the property of exponents here that I'm going to use is the product property that says if the bases are the same and I'm multiplying, I add the exponents. So what's negative 3 plus 2? It's negative 1. Okay, so now I'm going to go ahead and do my y's. So I have y to the 5th times y to the negative 7th. And again, property I'm using is the product property, which says if the bases are the same, I keep the base and I add the exponents. So what's 5 plus negative 7? It's negative 2. So why is this not simplified? It's because I have negative exponents. So remember, a negative exponent says I'm in the wrong part of the quotient. So remember, this is technically all over 1. So who has to move? So the things that have to move are the bases with a negative exponent, and that would be my x to the negative 1, and my x to the negative 1 and my y to the negative 2. So 45 is going to stay in the numerator. X to the negative 1, when I move it to the denominator, it becomes x to the positive 1. And y to the negative 2, when I move it to the denominator, becomes y squared. And remember, you don't have to write an exponent of 1. So we would write this 45 over the product x times y squared. Now this one's a fairly easy one because I have a common base, and there's actually I just want to show you two ways that you could do this one. Okay, one is that you could go ahead and use the quotient property first. So the quotient property says that I go ahead and if I'm dividing and I have the same base, I subtract the exponents. So I have m to the negative 3 minus 5, which would give me m to the negative 8. But if it's simplified, I can't have a negative exponent, so that tells me that m to the negative 8 isn't my final answer. So if it's in the numerator, I want to reciprocate it and make it go to the denominator to make it positive, and I can't leave the numerator empty, so I put in a 1. My second way of doing this is I could go like this. I could say comparing exponents, and this is what I often do myself. I go ahead and I say, okay, where do I have more m's? Do I have more m's in the numerator, or do I have more m's in the denominator? And in this case, I see that negative 3 is less than 5. So that means I have more m's in the denominator. That's my little head game I use, which tells me that my m's are going to end up in the denominator. So I still am going to use my quotient property, and I'm going to subtract. But I'm going to go ahead and I'm going to subtract this way. I'm going to do 5 minus negative 3. And 5 take away negative 3. Remember, when you're subtracting a negative number, it means to add, and that's going to give me positive 8. So by doing that, I don't have to worry about doing the reciprocating. Okay, last one. So remember that you always want to do these in parts. So we have our coefficients, we have our common base of t, and our common base of v. So let's go ahead and deal with our coefficients first. Those are the easiest. So what do 32 and 12 have in common as far as what they can both be divided by? They have a common factor of 4. So 32 divided by 4 would give me 8, and 12 divided by 4 would give me 3. So now I'm going to go ahead and I'm going to use so I'm simplifying this right now. And so I'm looking at it and I'm saying to myself, okay, where do I have more t's? I have more t's in the denominator. So I'm going to go ahead and take all of the t's in the numerator away. And I have t squared left. Okay, so now I'm ready to go ahead and I'm going to do my v's. So I have v to the negative 4th, v to the negative 6. Now, which number is greater, negative 4 or negative 6? Now, with negative numbers, remember, the one that's closest to 0 is the biggest number. So this actually is the greatest value. So that means my v's are going to end up here. And I'm still using the quotient property where I'm subtracting. So I'm going to go negative 4 minus negative 6. And remember, when you subtract a negative, it means add the opposite. So negative 4 plus 6 makes 2. So these go away, giving me positive 2 for the exponent of my v. So the quotient becomes 8 times v squared in the numerator, all divided by 3 times t squared.